Petrus Matheus Marie, Peter, Jenniskens, born the 2nd of August 1962 in Horst, is a Dutch and American astronomer and a senior research scientist of the Carl Sagan Center of the SETI Institute and at NASA Ames Research Center. He is an expert on meteor showers. Jenniskens is the author of the 790-page book, Meteor Showers and the Parent Comets, published by Cambridge University Press in 2006. Jenniskens is president of Commission 22 of the International Astronomical Union, 2012 to 2015, and was chair of the Working Group on Meteor Shower Nomenclature, 2006 to 2012. After it was first established, discovered at Ondřejov Observatory by Petr Pravec. Asteroid 42981 Jenniskens is named in his honor. In 2008, Jenniskens, together with Muawia Shaddad, led a team from the University of Khartoum in Sudan that recovered fragments of asteroid 2008 TC3 in the Nubian Desert, marking the first time meteorite fragments had been found from an object that was previously tracked in outer space before hitting Earth. NASA multi-instrument aircraft campaigns. Meteor Showers. Jenniskens is the principal investigator of NASA's Leonid multi-instrument aircraft campaign, Leonid MAC, a series of 4 airborne missions that fielded modern instrumental techniques to study the 1998-2002 Leonid's meteor storms. These missions helped develop meteor storm prediction models, detected the signature of organic matter in the wake of meteors as a potential precursor to origin of life chemistry, and discovered many new aspects of meteor radiation. More recent meteor shower missions include the Ondřejov Multi-Instrument Aircraft Campaign, Ondřejov MAC, which studied a rare September 1, 2007, outburst of Ondřejovs from long-period comet C. 1911 N1, KS, and the Quadrantid Multi-Instrument Aircraft Campaign, Quadrantid MAC, which studied the January 3, 2008, Quadrantids. Jenniskens identified several important mechanisms of how our meteor showers originate. Since 2003, Jenniskens identified the Quadrantid's parent body 2003 EH1, and several others, as new examples of how fragmenting comets are the dominant source of meteor showers. These objects are now recognized as the main source of our zodiacal dust cloud. Before that, he predicted and observed the 1995 Alpha Monocerotids meteor outburst with members of the Dutch Meteor Society, proving that stars fell like rain at midnight because the dust trails of long-period comets wander on occasion in Earth's path. Spacecraft re-entries. His research also includes artificial meteors. An overview of ongoing missions can be found at 1. Jenniskens is the principal investigator of NASA's Genesis and Stardust entry observing campaigns to study the fiery return from interplanetary space of the Genesis. September 2004. Stardust. Yan. 2006. And Hayabusa. June 2010. Sample return capsules. The beautiful re-entry of JAXA's Hayabusa probe over Australia on 13 June 2010 also included the disintegrating main spacecraft. These airborne missions studied what physical conditions the protective heat shield endured during the re-entry before being recovered. More recently, Jenniskens led a mission to study the destructive entry of ESA's automated transfer vehicle, Jules Verne, on 29 September 2008. Orbital ATK's Cygnus OA6 re-entry on 22 June 2016. And the spectacular daytime re-entry of space debris object WT-1190F near Sri Lanka to practice a future observation of an impacting asteroid. Small asteroid impacts and meteorite recovery. 2008 TC3 fragments recovery. The recovery of fragments of asteroid 2008 TC3 marked the first time fragments had been found from an object that was previously tracked in outer space before hitting Earth. This search was led by Peter Jenniskens and Muawia Shaddad of the University of Khartoum in Sudan, and carried out with help from students and staff of the University of Khartoum. The search of the impact zone began on December 6, 2008 and turned up 24 pounds, 11 kilograms, of rocks in about 600 fragments. Sutter's Mill. The next biggest impact overland occurred in California's Gold Country on April 22, 2012. One of the fragments landed at Sutter's Mill, the very site where gold was first discovered in 1848 that led to the California Gold Rush. Jenniskens found one of 3 fragments of this cm chondrite on April 24, before rains hit the area. The rapid recovery was made possible because Doppler weather radar detected the falling meteorites. A consortium study led by Jenniskens traced these meteorites back to a source region in the asteroid belt, a family of asteroids that move at low inclination and are close to the 3.1 mean motion resonance with Jupiter. These were the first cm chondrites to be recovered from near the surface of the original parent body before it broke up, creating the asteroid family, Novato. Half a year later, in the evening of October 17, 2012, a bright fireball was seen near San Francisco. The first Novato meteorite, L6 type chondrite fragmental breccia, was found by Novato resident Lisa Weber following Jenniskens' publication of the trajectory of the fireball from video recorded by stations of his cameras for All-Ski Meteor Surveillance Project, Chelyabinsk. 3 weeks after the February 15, 2013, Chelyabinsk meteor, Jenniskens participated in a Russian Academy of Sciences fact-finding mission to Chelyabinsk Oblast. Over 50 villages were visited to map the extent of the glass damage. Traffic video records were collected to map the shockwave arrival times, in order to determine the meteoroid entry speed and angle. Star background calibration images were taken and shadow obstacle dimensions were measured at sites where video cameras recorded the fireball and its shadows. Eyewitnesses were interviewed to learn about injuries, heat sensations, sunburn, smells and where meteorites were found. Meteorites found shortly after the fall by Chelyabinsk State University colleagues were analyzed, and the results from this consortium study were published in Science. Other research. In earlier collaborations, he discovered that an unusual viscous form of liquid water can be a common form of amorphous ice in comets and icy satellites. During a postdoc study with David F. Blake, and he created the first broad detection limited survey of diffuse interstellar bands in his PhD thesis work with Xavier Desert. References.